Good morning, my YouTube viewers. Crystal here. What I wanted to do was I wanted to present to you today a solution to the Kaggle house price competition with the Ames house prices. I've got quite a few solutions to this competition because, obviously I keep trying to get my score up on the leaderboard. And the most recent solution that I have was the linear regression and gradient boosting, which gave me a 13.976% RMS. But that's not my best score. My best score was Amy's house prices XG regression. That was 13.713%. So what I might do at some point is I might try to incorporate the linear regression into the XG regression and see if that improves my score. And the reason why is because I was reading that one way you can improve your score is you can top the models up on top of each other to help increase your score or improve your score, which is what this is. This particular solution that I'm going to show you has two models in it. As you can see that I did it this morning and I got a 13.976%, which isn't my best score, by the way, but what I will do is I will try to incorporate this linear regression into my best score and see if it makes it even better. You can see my submissions. I was actually doing some work on Keras, trying to use Keras, hoping to improve my score above my highest score, which was the XG regression. But Keras, as you can see from my scores, Keras did not give me the highest score, sadly. And I tried all last night to increase the score by changing the epochs and changing the batch sizes and adding more layers, and it just, no matter what I did, it just wouldn't improve. So what we'll do now is we will go over this solution of linear regression and gradient boosting, which I was able to do this morning. So the first thing I did was I imported the libraries. The second thing I did was I imported some more libraries. And then what I did was I read in the Amy's house prices files, your test file and your train file. I loaded the data sets so you can see the train file and you can see the test file. You can see info on the train file, and as you can see, this is a very large file. It had 81 columns because the first column starts with 0. I looked at the test file, which has the same amount of columns, except it didn't have a sell price. So we did a disk plot of the train sale price to see the average prices of the houses so you could see for yourself. And if we had wanted to, I think we could have used a logarithm function, and the logarithm function would have taken the house prices and moved them to the center somewhere. So what we did was we compared the sale prices to the overall quality of the houses. And so you can see, the higher quality, the higher the price. We did a chart on the sale price to see the number of bedrooms. We did a chart to compare the price versus the living area. We did a chart to compare the price against the total number of rooms. We did a chart to compare the price against the total basement square foot. So the basement square foot is integral to the price as well. There were a lot of basement basement columns talking about that. We did a chart to check the overall condition of the house in comparison with the sale price. And now what we did was we inserted some coding to check for any null values. And as you can see, there were quite a few null values in the train set and the test set. And what some people will do is they will just do a blanket null value to get rid of all the null values in the whole data set. But I didn't do that, because if you got rid of all the null values in the whole data set, you would be getting rid of a lot of information. So what I decided to do was replace the null values with the mode. So this is the coding for the mode. And then we had some instances where I replaced the null values with 0. And so this is the coding to replace the null values with 0. We went to check to see if we had any more null characters, and after we replaced all those values, we did not have any more null characters. And then we did some more works with categorical values, so we changed some of the columns to categorical values. So after we manipulated this data, you can see the train file and you can see the test file with all the data manipulated. So now what we've done is, in order to prepare the data to be predicted upon, we combined the train file and the test file, and we dropped the sale price from the train file. So now you can see the combined file. So we dropped the ID from the combined file, and we did our get dummies coding. So you can see the train file after we combined everything. And you can see the test file. So we set up our Y value. Y equals the DF train sale price values. And we decided to drop a bunch. I just decided to drop all of the columns that were strings. All of the columns that were objects, I decided to drop them. And then in addition to that, I decided to drop some more things like garage year built, miscellaneous value, month sold, year modeled ad. And the reason why was, before I dropped those items, I had 31 inputs. And I was just worried that it was so many inputs that it was going to confuse the models. So I went ahead and made the decision to drop a few of the numeric inputs as well. So, and this is your output. The output just tells you how many columns you have after you've dropped everything. And I did the same thing with the test file. So now you can see the train file, which does not have as many columns, and the test file, which now it does not have as many columns. And then now we have a heat map based upon the new columns. What I did here was I set up columns, and this columns is just how many columns we have in place that we're going to be using, which I think is about 26 columns. but I didn't actually do anything with it in this particular file, but I decided to go ahead and keep it there just in case I need it at a later date, because I'm always working on these files trying to improve my score, and since I went to the trouble to type it all up, I'll just leave it in there, and then if I need it at some point, I'll use it. So we set up our X value, which is DF train drop sell price, and we set up our Y value, which is DF train sell price. The next thing we did was we created matrices for sklearn. X goes all the way up to the end of the train file, and test values goes from the end of the train file and beyond. We decided to set up our first model, which our first model is linear regression. And then we split our file up into train test split for testing in order to get the score up as high as I could get the score up. The train file is 90% and the test file is 10%. I wanted to see the X value, and then I wanted to see the Y value, and I wanted to see test values. And then what we did is we set up the min-max scaler. So we scaled all the values to be close to the same range to try to improve our accuracy. So now what we've done is we fit our first model, reg fit X train, Y train, and we scored it with a value of -8. And now what we do is we have another model called CLF, and it's Ensemble Gradient Boosting Regressor. And I did actually experiment with that to try to get my score up, and that's the score I came up with, the best I could do. So we fitted our X train, Y train, and we've got our score of 92%, which is good. Now we set up our Y-PRAD, which is the prediction on X test, and you can see Y-PRAD. And we set up our final labels, which is the prediction on test values, which is the combined file beyond the train file. So now you can see the final labels, and it's an array. So I just wanted to see the final result. They put it in a data frame, and you can see the final result. And then the final result, what we did was we put it into a CSV file, and you can see the submission. And this is what I submitted to Kaggle. And what I'm going to do is I submitted this to Kaggle, and I worked on it all day yesterday. Well, basically, I was working on Keras all day yesterday, and I couldn't get the score in Keras to go down. So I decided I was going to try something else. I decided I wasn't even going to make a video on it because the score wasn't good enough to make a video. And then I started working on linear regression and gradient boosting, and just wanted to show you that it's taking me a while to do it because I did a lot of work on this. I just wanted to show you that when I submitted it to Kaggle, my public score was 13.976%. Now what I'm going to do is I'm going to share this with you. So if you want to look at this, you can. It's not the top score, but it's a good score. It's not the best score I've been able to get, but it's a good score. And if you want to use this algorithm, you're more than welcome to use it. So that's it for my solution to the Ames house prices competition. If you like my video, please like, subscribe, and share. If you like the work I do, I've got my email address for PayPal donations down below. And the reason why is because I don't have enough subscribers to be monetized. So the only way I can make money on my channel is to ask for donations. And thank you so much for watching this video to the very end, and I look forward to making another video for you.